What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we continue our work with geometric sequences and series. In this video, we are going to focus on the partial sums of a geometric sequence. So if you haven't watched the previous two videos, make sure you go back and do that before embarking on this journey with us. Today, we have a formula for finding sums of a geometric sequence or a geometric series. And this is similar to the formula and components that we saw with arithmetic series. F sub n is going to be a series, a partial series, but a series with n number of terms. And that's going to be equal to a sub 1, which is the first term, times the quantity 1 minus r, where r is, as we know, the common ratio, to the nth power, where again n is the number of terms. And this is all over 1 minus r. So this formula is going to allow us to find the series, or a partial sum, for any geometric sequence. So let's go ahead and take a look at an example. In problem number 7, it says, for the following, find the indicated partial sum. So we want to find the sum for the first 8 terms of a geometric series that starts with 2 and has a common ratio of -3. So I'm going to go ahead and substitute into this formula. So this is a sub 1 is going to be 2. And this is 1 minus -3 is my common ratio to the 8th power. Now be careful here. When you substitute in this -3, you do need to make sure the -3 is in parentheses and then to the 8th power. You cannot combine this negative with that because we have an exponent of other than 1. In the denominator, if I substitute in, I would have 1 minus -3. And because my exponent here is 1, I can change this into 1 plus 3. So this expression represents the sum of the first 8 terms for our geometric series. Now I can use my calculator to evaluate this expression. So I'm going to input this calculator as it is written. Input this expression into my calculator as it is written. And I'm going to simplify down here on the bottom and just divide by 4. So the sum of the first 8 terms here is going to be -3,280. So what we would find if we listed out the terms, that terms would alternate from positive to negative values, and then if you add them all together, you're going to have a -3,280. Let's take a look at problem 7b. In this case, we're given the sigma or summation notation, but it's going to be a series of 9 terms, starting with 1 and going to 9. So our first term would be as if we substitute in 1 for I. I is a variable in this case, not imaginary number, so don't be confused there. I'm going to substitute in 1 for I to get my first term of 3. Now, inside my parentheses, I'm going to have 1 minus the common ratio. If you can recognize that the common ratio is 3, excellent. You don't need to do any work. But if you're not certain of that, we could type the expression 3 to the x power into our calculator and look at the table. We would notice that each one of these terms has a difference of 3, thus my common ratio would be 3. So in my equation, I'm going to have 3 to the 9th power, as n is again the number of terms, in this case 9. Then in the denominator of my fraction, I would now have 1 minus 3. So I can evaluate this expression in the calculator. 3 times the quantity 1 minus 3 to the 9th power divided by -2, is 1 minus 3 is -2, would give me the total value for this series, which would be 29,523. Let's look at one more example of how to use this formula. Problem 7c, they're giving us 3 terms in the sequence. So they're showing us the addition of these terms and telling us to find a series up to 7 terms. See if you can pause the video at this point in time and find the value of that partial sum. Hopefully you've gotten a chance to find the value of the partial sum, and this is going to be a series of the first 7 terms. So the first term is given to us explicitly there. It is 4. Then in parentheses, I would have 1 minus my ratio. My ratio in this case is we see is moves from 4 to negative 12. Notice that is a negative 12 to 36, and then to some other negative number. So we can see a consistent sign change here. I can also multiply by 3 to change those numbers. So if I multiply 4 times negative 3, that's negative 12. Negative 12 times negative 3, that's positive 3, and so on and so forth. So my ratio here is negative 3. Again, make sure that negative 3 is in parentheses before you apply the exponent of 7. In the denominator, I would have 1 minus the negative 3 to the first power, which can be combined as 1 plus 3. Now, quickly, I'm just going to do some mental math. If 1 plus 3 is 4, and so these two values, this 4 in the numerator and this 4 in the denominator, would actually eliminate each other. So in my calculator, all I need to really value is what's inside the parentheses. Now, that's not always the case. So if you want to input the entire equation into your calculator, you certainly can do so. But in this case, we can take a little bit of a shortcut, and we can find that the series of the first 7 terms would be 2188. So here we have some examples of finding partial sums of a geometric sequence. As always, thank you guys for tuning in, and I'll see you soon.